Hi, everyone. In this talk, I want to talk to you about all of the day two operations of Yugabyte, including what are the operational best practices when it comes to zero downtime upgrades, monitoring, alerting, and securing the cluster, and how we went about automating all those things. Joining me today, I have John, who will be doing a live demo later on in the talk, in which he'll do a live demo where he takes down a node in the cluster and shows how Yugabyte responds and recovers. So quick background on myself. My name's Taylor. I'm a data engineer here at Yugabyte. Started working here last year. Before that, I was at DataStax for a few years working with Cassandra. Before DataStax, I worked at Spectrum, helping them build their new guide platform. And John, would you like to do a quick intro?
Yeah, hi, my name is John Forrest, based just outside Boston. Prior to joining Yugabyte, where I'm the director of ATS, I worked for Data Robots, and before that, Netezza, and various other database companies along the way, like IBM DB2, Informix, and so on. So great to be at Yugabyte now. Thanks, Tim.
Awesome. Thanks, John. All right, so let's just jump right in. So before we actually get to the operational best practices of Yugabyte, I just want to take a couple minutes to talk to you about the database reliability engineering, or the DBRE model. It provides a set of guiding principles of how you need to design and operate a resilient database. It's inspired by the Google SRE model, which many companies use now. Back in 2004, when Google had those massive scaling requirements, they couldn't go in and do stuff manually. They couldn't go in and create VMs manually, and they're seeing a lot of infrastructure as more of code. They had the concept of automating everything they had, including the infrastructure provisioning and installing all the software on that infrastructure. They did this because of the massive scale they were working with in deploying applications across the world in different data centers. So that's why they wanted to automate as much as they can using all the lessons they learned through this process, they came up with all the best practices and design principles of how you can automate your software. So generally, DBA teams are siloed. They act as custodians of data. You have to go through a bunch of different ticketing systems to even talk to them. Even a slight schema change, you'd have to open a ticket, which can take weeks to get through. And if you want to create a database, it could take months. Those things don't really fit into the cloud native way of developing software. So that's why we're concentrating a lot of things about being as fast and agile as possible. So DBRE provides guiding principles where it shows how a traditional DBA evolves and has a collaborative way of doing DevOps and working with those teams. So rather than being a custodian of data, the task will be changing to where they're providing that knowledge around the patterns and best practices and how you deploy clusters in a production system and how you implement access patterns for relational workloads. So why are we talking about these things? If you take a step back, let's see what cloud native definitions itself talks about. If you see what the cloud native definition says, it says to empower new organizations. It says to empower new organizations, you need to be able to build and scalable applications irrespective of what environment. It can be deployed in a private cloud, public cloud, or can be deployed in any form factor like containers. Your application needs to be scalable. Obviously, when it comes to stateful applications or stateless applications, those are pretty easy to scale, but stateful applications, that becomes a little more difficult, which is why you need to be able to scale for the modern cloud native way of developing software. In the second half, if you see, it says you need to be able to have resilient, manageable, and observable systems. If you put this all together, what it's trying to say you need to do is have a really good automation around your database. So the traditional databases like the Oracles of the world were designed in a previous era where all these things, they just didn't matter as much. We used to have a single configuration, which was called the golden copy that was sitting in one data center. And if that data center or the database itself went down, everything goes down along with it. There'd be massive impact to your application and your business. That's the reason why they had all these ticketing systems in place so that you would avoid the major outages. All of these things go away in the new way of doing things, in the cloud native way of doing things. That's why Yugabyte team put all these theories that we talked about and came out with a product called the Yugabyte Platform. This platform is an enterprise offering which deploys and helps operate the Yugabyte database. So if you don't really know the founding members of Yugabyte, they were at Facebook before this. They're core code engineers when it came to developing Cassandra and HBase. They had the experience of building these massive scaled applications. So all the learnings they had on how to productionize for the massive scale, they wanted to bring to enterprises as well. So that's why we have some of these design decisions in order to automate our system. We have a very robust way in how we do automation in our project. Everything can be API driven. recovered in an API, the configuration and change management, everything is in one place in the platform, where it acts as a vault where everything you need in your database is centralized. So let's take a quick look at the platform. So here's the platform. This is where you can automate and provide the database as a self-service for our users. So the first thing you see is a number of different clusters that are deployed right now. This is our internal dev portal. We can deploy and manage these clusters. What's great here is a dev can come in, deploy a universe with just a couple clicks of a button. So let's switch back to talking about the tenants. The first tenant talks about self-service. You need to provide enough capability for developers so that they can implement things faster. It actually applies to databases as well, where you have to provide a very robust way of deploying or self-servicing your product. It doesn't matter where you are deploying it. It doesn't matter which region you're deploying in it, or if you're even deploying multiple regions in different clouds. Your self-service capabilities and the automation tools should be so robust that depending on the developer's needs, it should support the creation of these databases in these environments. So to quickly go back to the admin console. So if we go over to the config section, what we can see is there's a variety of different providers that we can use. You can do things like AWS, GCP, Azure. There's even been some new ones like VMware Tanzu. In addition to that, you can see a bunch of Kubernetes providers as well. It's super popular these days to deploy databases on Kubernetes like EKS or GKE. We can go ahead and deploy those as well. Once we have a cloud provider configured, as an app developer, I can go to dashboard and create a universe. And really, a universe in Yugabyte terms is just a cluster itself. The reason why we changed that name is that a cluster can actually scale across multiple regions across the continent. So when I go to create a cluster as an app developer, I can pick whether I want whatever provider I want. So in this case, say I'm already running an app in GCP, but I want to see how the performance is on AWS. So I can kind of have them run against each other and see what has the best performance. So what I can do is I can go ahead and click the AWS. I can call this YB AWS. And from there, I can pick different regions. When I pick a region, what you can see is that the availability zones automatically pop up on the right. If I were to try to take away these availability zones, you'll see that I actually do get some warnings saying that my data wouldn't be redundant because I have all the data in one availability zone. So if I lose that, I'd actually lose data. So along those lines, you can actually also enable TLS encryption and encryption at rest. All these advanced capabilities are right there, which actually is usually where a DBRE team would come into the picture, where they work with the developers to figure out whether they need these capabilities enabled. Obviously, when you go to production, these types of things come important. And it's the work of the DBRE to take care of all these things. Other things you could do is select the different instance types. You can do C5x larges and really increase the number of cores or memory that you have for these machines. This is a place where you can kind of put guardrails around what you can do and what your developers can do. So that way you can build a robust self-service method and a self-service way of deploying the cluster. So back to our slides. We have a couple of different deployment topologies that are commonly used. The first one and most common is a single region multi-zone deployment. This is sufficient for probably about 50 to 60% of the users who just care about availability zone failures. So in this case, even if you have an entire AZ fail, you shouldn't have any data loss and you shouldn't have any downtime in your app. Also, you still have a higher throughput and lower latencies since you're deploying a very localized location. The second option people generally take is a single cloud multi-region deployment, where you may want to have data on the East Coast, the West Coast, or in the central area. And this can survive a full region failure without any impact to your application. The last option we sometimes see is a multi-cloud, where you may have a mix of both public and private cloud. This is a great option when you don't really want to invest in your physical data centers anymore, but you want to scale out your database to multiple regions. So here are a couple examples from our customers of what they're running in the production now. So for this customer, what we can see is that each of these clusters has about 15 nodes deployed across 3 different AZs, and each node has 5 nodes. So they can have up to 5 nodes fail and still be able to serve consistent data. If you notice one thing, they have high data density while also having high availabilities. Those are some of the major reasons why they picked Yugabyte. And if you see, they also did a couple of different upgrades going from 1.19 to 2.2.0. That's something we built in the product where you can actually move from one version to the next very seamlessly without any downtime. Now, another one of our customers, they've actually been in production for about 300 days with 0 downtime. It's a large production cluster. It has about 2 terabytes of data per node. So we have a large clusters running right now in production that are able to scale and stay stable and reliant so it can handle whatever SLAs or SLOs that you have in your workloads. And that kind of goes along with our next tenet, which is the automation. The automation that we built in this product, so some of the automation we already have built in are things like scale up, scale down, creating a new cluster, which we kind of saw on the platform as I was showing you. All of these things are REST API driven. So we showed you how to do this with the UI. You could do all these things with API calls as well. You could build a robust pipeline where whenever you see an outage, based on some of the alerting you set up, you can quickly go ahead and create a new cluster in a different environment. So you're comfortable making production changes without having to wait for those maintenance windows because of your automation. Another very important DBRE principle is data recoverability. Data recoverability directly ties into your business continuity. Some of the things that people talk about with data recoverability is RTO and RPO. If you don't know what RTO is, it defines the uptime you need for your business continuity. You want to have that pretty close to 0. Businesses move to the cloud because you want to have apps which can take outages and still be able to run. Even if there is an infrastructure outage, you still should be able to continue to run your app. That's why we talk about all these scaling, HA, redundant copies, replication factors, and things like that. As I said, generally we want RTO to be 0. RPO is something that ties down to how much data loss you can take in backing up your backing database or your transactional database. Obviously for this, you need to have a really good backup strategy for backing up all your transactional data. You need to have a data validation pipeline as well. What we mean by data validation pipeline is you need to be able to restore your backup data into a different cluster and verify whether or not all the data is intact. So we'll go check out data recoverability in the platform. So if we go to one of these currently running clusters, we can see there are a bunch of different tables. And inside of these tables, we can go ahead and create a backup. So with these backups, what you can do is you can obviously pick a bunch of different ways to actually store this. So you can do NFS, S3, all those things that can be configured in the cloud itself, cloud config itself. And you can also encrypt your backups if you need. You can specify how fast you want your data to be backed up, and you can also configure the cadence at which you want backups to be taken. You could do it hourly, you could do it daily. It's really up to you on how often you want those backups being taken. All those things tie back to your RPO. One of the great things about the platform as well is the ability to back up data in one cluster and restore it into another. This allows devs to have an environment where you can have real prod data that they can work with and interact with without causing any impact to your production environments. So let's go back to the slides. So being around the same topic, this is how self-healing works within Yugabyte. Say one of the zones went down. That usually, when this happens, Yugabyte figures out that there is a failure in the cluster and auto fails over the tablet to a secondary, wherever it is, even if it's in another zone. So there's no downtime for the clients. John will go in more depth with this later on in his demo. Next thing is config management, which we talked about a little bit earlier, but you need to always have a central place where you can manage your configurations. Obviously, things like CA certificates and the KMS and security integrations, all these things you just don't want lying around in the open. So in a future roadmap, actually, we're going to be having integrations with Vault, which is a super popular these days to maintain, and it will help maintain all these secrets. That's why with Yugabyte, we have taken a lot of care about how the configuration management with the cluster itself works. You don't need to go outside of this portal to maintain or manage your database in production. Everything is in the same localized area. Another important thing the DBRE model talks about is monitoring and health checks. It's super important to have monitoring and know what's happening in your cluster. Without any monitoring in place, you'll need to have people looking at your cluster and monitoring each system. If you're doing things like upgrades, you'd have to do that in a maintenance window. And even if you're in that maintenance window, there would still end up being downtime, which is more of the old way of doing things. All these things does not really fit into the cloud native way of building software, which is why monitoring becomes so important. With monitoring, there's also the fact that you want to be able to have a good incident response platform, like PagerDuty, where whenever you alert is set, like say disk utilization over 80%, and you need to take like in a preventive reaction, like adding more disks or nodes, you get a pager saying that there's something wrong with the cluster and you can go fix this. All of those integrate really well with Yugabyte. So let's take a look at some of what I was talking about here. So here's the metrics page that we have. What you could see here is you can see things like latency, the ops, and what's happening in the cluster. You can also get node level details about CPU, memory utilization, disk ops, and network operations. It provides you a quick overview of what's happening in your cluster. On top of that, we also have a generic health check. You can already see here that we actually have a health check failing. So if this were to happen in your production environment, you would actually see an email get sent to you with whatever email you set up. If you also have this integrated pager, a pager alert would go out immediately, so you can help fix this, whatever issue this is, in this case, connectivity with SQL/SH, and get the cluster back up and running. So back to our slides again. Another important thing with deploying and managed data is being able to secure it. You want to be able to enable SSL communication between your internal clusters as well as client to server connections. Because we're deploying across the cloud, even though you have a tunnel between those cloud VMs, we still don't want the data going across in plain text. That's why it's important to have TLS with these integrations. Whenever we provide the AWS KMS or some kind of custom CA authority through the platform, we want to make sure that's protected, and that if we need to, the platform automatically rotates those keys. As an app developer or the operator of the database, you don't want to manage those things. We have the capabilities of securing the data on disk. We have different ways you can encrypt the data. You can use AWS KMS provider, or you can use a third-party provider like Vormetric to encrypt your database. We also have the capability of encrypting your backups, so the backups also aren't in plain text. All right, so that's perfect. We went over some of these top tenets in the DBRE model and how we design our automation to implement them in production to make it cloud native. Now, John is going to walk us through a short demo on how some of these things work in action by taking down a node and seeing how Yugabyte recovers.
Okay, thank you, Taylor. That was great. And also thank you for volunteering to stay up for the live Q&A. So Taylor's online ready to answer all the questions. Please keep them coming in. Right, so transitioning over to the demo. What we're going to do is I'm going to play the role of DevOps person from hell who makes a really terrible mistake, right? So I'm going to go and kill some stuff and show what happens. I'm going to try not to repeat everything that Taylor showed you, but we'll have a quick run through just to set the scene. So first thing, never start with an apology, but I will. I decided to design the cluster based purely on getting this graphic looking good for Asia, right? So I've got a 3-region cluster split between Tokyo, Sydney, and Taiwan. Okay, so latency in this is not ideal, but for what we're doing today, that doesn't matter, right? It's not about performance, it's about functionality and availability at the moment. Good, right, so let me go back from that. So this is the Yugabyte platform called Yugaware, right? So it's our enterprise offering, our commercial offering. It supports a single pane of glass to manage multiple universes, so multiple Yugabyte database clusters from a one location. Everything I do through the UI, I can also do through an API. So we can CI/CD and put this, in scripted and so on. Also, all of the metrics coming from the clusters will be available through Prometheus, and you can be monitoring what's going on in whatever your tool of choice is. And finally, the alerting, as Taylor said, can be fired off. So we don't have to live in the UI, but it does give us a nice view of what's going on. Okay, so let me just quickly recap. So this is running in Google. So if I go to my configs, you'll see I've put my parameters into the GCP environment, and it's gone and pulled up all the regions and availability zones available to me. And the account's going to make available the different instance sizes and subscription elements I've paid for. Okay, we can do the main cloud vendors, Kubernetes, all lots of different flavors, OpenShift and so on, and on-premise, right? Backup gets configured in here. I've just stuck a /NFS as a bit of a cheat, but it could be the Google storage, S3, Azure, whatever. And then I've not turned on encryption, so no encryption at rest. no TLS to either the database or the thing just for a demo, but that's all managed through here as well. Let me go back to the universe. So just to show you the configuration, I can show you how it was created by going to the edit universe. So this is how I change the universe. This is also how I might want to go and add more nodes. So if I bump the number of nodes up here and save, it'll go and provision another 3 nodes, 1 in each region. And you'll see the cluster's designed to go across failure domains, right? So I've got Asia East 1, Northeast 1, and Southeast 1. So those are the 3 failure domains. I've got a replication factor of 3. So it's going to be monitoring put a master in each of these 3 domains. It's going to make sure there's a replica of the data in each of these 3 domains. And it will maintain that if I change anything, it'll rebalance. And that's what we're going to see in the demo. In the interest of full disclosure, the other thing I'm going to say is I've changed 1 default parameter. Everything else I'm doing is default, single default parameter, which is just saying, when I fail a node, don't wait the normal 15 minutes. Typically, by default, we would leave the node available for 15 minutes and assume there's some kind of network glitch, network recovers within that 15 minutes, the node will be brought back into the cluster automatically. In this case, I'm going to have it drop out very quickly. And then relatively small nodes, so N1 standard 2s, there are 9 of them, 3 in each of those domains. So let me cancel that. The workload I'm running, I've got a fairly light workload. There's about 13 gigs of data. It's a YSQL, so it's hitting the Postgres API. And you can see there's a few hundred transactions per second. The latency of the writes is fairly high. That's mainly due to the crazy cluster I set up, and the read latency is down, single-digit milliseconds. Relatively complex SQL operations going on, but we're not going to get into the detail. It's really just to show a consistent workload and what happens. So jumping in, if I go to the nodes, I can see the 9 nodes. And what I'm going to do is, as I said, be the DevOps guy from hell and do really stupid stuff. So pick one of the nodes. I'm going to pick N8, I think. Just talking about this screen a little bit, so I can see the nodes. I can see the 3 masters. So there's 1 master per failure domain. So if I've got RF3, replication factor 3, I'm going to have 3 masters. And then TServers are the tablet servers. Just a reminder on our architecture, the tables are sharded. The default number of shards per node is 8. I've not changed the default, so there are 8 shards per table per node. And the leaders, let me just go back and show that again. I should have said that on here. I can have some control over where the leaders are, right? So if I want, because I'm always going to write, and in YSQL, I'm always going to read from the leaders, then I can geolocate leaders with different data centers, different regions. Not time in this discussion to talk about GR partitioning or anything more complex. Really, we want to get on and see the failure, right? So let me cancel that again. Go back to the nodes. So I've got 3 masters, 9 TServers spread across 3 regions. And I'm going to kill one. I'm going to do something inappropriate. So let me go back. I'm going to just pick lucky N8, not 7. There we go. And I'm going to delete it, which is not the ideal way of operating. I'll show you what that is. So I'm going to kill it now so that it can go and fail. Take that 60 seconds. Okay, so delete the instance. You can see Google Cloud's going off and deleting it. On the admin console, I'll show you how we monitor it, but what I will do for N8, I've got various operations I can do on a healthy node. I can, is that the healthy one? Yeah. So I can stop the processes on the node, so I can take it out of service for a bit and then restart them. I can remove a node. When I remove a node, I'm just saying it's not actively participating in the cluster. And then I can go and actually release the instance. So we'll go through the process of re-adding. What I want to do is go and look at one of these TServers. So I click on this TServer. It's going to bring up, it's going to give me a web portal onto the TServer, the database server node itself. and it shows me the tablet server. So this isn't a big data set. So already what will have happened is it will have, sorry, tablets, it'll already have started the rebalancing. So yeah. So you can see the nodes are running, and sorry, I should have gone to a master, not a TServer. I'm going, where's the bit I need? Went to the wrong place. I'm going to go to a master. And this is connecting to a web UI to the master again. I can get this through curl requests. You can see, is the load balanced? Currently there's a red flag. No, it isn't. If I look at the workload, go back to the overview, there's going to be a little spike while it rebalances and gets things sorted out. So latency went up, the read throughput, we lost a few hundred transactions, but we'll come back and see how that recovers from that. Really what I'm interested in is the rebalancing. So on the tablet servers, I can see the total number of tablets for the database and the number on the active node. So I just killed, you can see I ran this earlier. So I've got a couple of dead nodes. There were, this one's one from an earlier exercise, but here there's 192 tablets. There should be about 70 on each of the nodes in the cluster. This one's already rebalanced. So when we bring the node back in, we can go and see it repartition onto that. Okay, so failure is taken care of. It hit the 60-second timeout that I dropped. The redundancy is now maintained. You'll see that some of these nodes have got extra tablets on them, and it's rebalanced. It's rebalancing across the data across those nodes. The way it does that, I'm sure you've attended some of the architecture sessions, we have the SQL API on the top, and then DocDB handling the raft replication below, right? So we do that at a file level. So the rebalancing is very efficient because we're moving those tablets, those shards of data across the cluster. We're not doing individual rows. So it's very efficient. I'm going to go back now and recover from this. Let me just refresh that. I should see this workload pick back up any second. It's a little spike because I've got to do the rebalancing. Any transactions that were hitting the active leaders gone, but recovery's back up. So there's a spike in latency, a drop. I wasn't running a big workload, so it looks worse than it is, but a drop there. But we're back up and running and doing what we're supposed to do. So if I go back to this node, what I want to do now is recover from this. So sheepish DevOps guys come back and explained what they've done to our database. We go to actions, and I'm going to remove the node from the cluster. Okay, so remove node. You'll see that this shows up as a task. If I just refresh that, it's already complete. So the node removal doesn't take any time. I go back to the nodes. I can release the instance. Well, the instance is gone, but I still need to tell the Yugabyte Platform that the instance isn't there anymore. So yes, I'm going to get rid of that. And again, if I go to tasks, we'll see, just refresh that. That maybe takes a little longer. Nope, it's done as well. So it's released the node. So now it says, okay, there's no node there. If I go back to the node now, I can go and do an add node. So this is replacing a failed node in a cluster. As I said, if I go and edit the universe, I can, I've lost a node here, right? I can increase that number, or I can add it through that UI. What I would do here is I'd also increase the total number of nodes. So if I wanted to scale up horizontally, I can do that from this tab. So let me go back to universes, SQL Summit, nodes, and I'm going to add a node, and OK. In the interest of time, we don't have the time, sadly, to sit and wait for this to complete, but I can show you it in operation. What it will do is, well, let's actually look at tasks. This one's a little bit more interesting. You can see it's giving me a status bar. So because this is GCP, it has credentials to go and create a new VM. So it's going to go and provisioning the VM right now. It'll then install the software. It'll set any new flags. Once the software's up, it'll set those, start the node processes, bring the node up, and then wait for it to come into the universe, and then it'll rebalance the data and we're done. All of this while it's online, right? So both scaling out and repairing, same thing will be done online without any interruption to the service. Okay. And as I said, we're not going to wait to see this all the way through. But if we go back to an overview, we can see that the workloads come back. It's doing the rebalancing. So there's going to be a little hit in latency. So the read latency hasn't changed much. The write latency has gone up a bit as we're figuring out where leaders are moving and reorganizing, and the throughput is recovering. Okay, obviously errors, the bleeding heart over here is telling me things have gone wrong. We can go and look at the errors. So I think we've shown the resiliency, scalability across a geo-distributed database. We talked about how to create the provider. We talked about how to create a universe. We showed where to do the backups. I think the last thing to just finish up with is there's a little warning here saying I can do 2 upgrades. So in the more option, I can specify upgrade software, and I can choose to do a rolling restart or not. I can do a big bang, stop everything, upgrade it, and bring it back up, or I can do a rolling restart. I can control how long I wait for each node to come, so I can spread the impact to the application space over a longer period of time, and obviously choose which versions. So confirm upgrade and click go, and off it'll go and do that. Again, I'm not going to run that for time concerns. Okay, so I think that's it. Any questions? There'll be a live Q&A. Thank you, Taylor, for doing that and staying up late. You are 2 hours closer to Asia than I am, so I appreciate it. And thanks for your time.